So this is the second in the series of looking at d versus t and v versus t graphs and a versus t graphs in their relation. But this time, where there's not a constant slope to your d versus t graph, there are curves to it, which means that my object is either speeding up or slowing down. So in general, just looking at the shape, if I go from a very steep slope to flattening out, whether it's this green line or whether it's this purple line where it's going steep and then flattening out, that means that my object is slowing down. If I start out flat and start to become gradually steeper, that means that I'm gradually speeding up, right? So these are different, you can think of it as different aspects of a circle. So we're going to start with just one part. Here I have a green, in the green, I have an object that has a general positive slope, which means that it's going forward. And because the slope is starting to flatten out, my object is starting to slow down. So the two aspects of this motion of this object described by this d versus t graph is that my object is going forward and slowing down. Now you'll remember from our last video that if I have an object in the d versus t graph that has a positive slope that's going forward, that motion is going to be shown in the first quadrant of a v versus t graph. So certainly what's happening here, I have my green straight line in the v versus t graph, and it's in the first quadrant right here. Now, if I'm starting to slow down in my d versus t graph, what's happening is that my speed is going toward a standstill, which is 0 meters per second. So anytime I have an object that is slowing down, my v versus t graph will be going toward the x-axis. So in this case, it has to be in the first quadrant because it's going forward. And to slow down, it has to move toward the x-axis. So my v versus t graph will have a negative slope in the first quadrant. Right? First quadrant because it's moving forward, negative slope because it has to be going toward the x-axis. So if it's a negative slope in the v versus t graph, it's going to be a straight line horizontal slope because it's constant in the fourth quadrant for an a versus t graph. Negative slope means that the a versus t graph will have a negative value. It will be in the fourth quadrant. So going forward, first quadrant v versus t graph. Slowing down, going toward the x-axis. And I'm doing this at a regular pace, so it's going to be straight line. All of your v versus t graphs in this course will be straight lines. Whether they're horizontal or have a slope to them, doesn't matter, they will be straight lines. Because it's a straight line, it will be a horizontal line for the a versus t graph, and because it's a negative slope, it will be in the fourth quadrant. As we go through this, maybe it'll start to make a little bit more sense. So another type of d versus t graph is that I can go this type of curve. It's getting steeper, so I'm speeding up. And I have a general downward slope to it, so I'm going backwards. So the description of my pink graph would be going backwards, speeding up. If I'm going backwards in my d versus t graph, my v versus t graph has to be in the quadrant 4. So where it is, which quadrant, 1 or 4, is determined by the slope of my d versus t graph. If it's positive, first quadrant, negative, fourth quadrant. It's speeding up, which means I'm starting from close to a standstill and I'm getting faster. So I'm going to have moving away from the x-axis. Speeding up means moving away from the x-axis. The only way that I can have something that's in the fourth quadrant moving away from the x-axis is if I have a negative slope for my v versus t graph. So negative slope in my v versus t graph means it has to again be in the fourth quadrant of my a versus t graph. So I can have a negative acceleration either because my object is going forward and slowing down, or I'm going backwards and speeding up. And the reason why I have a negative acceleration is because acceleration is meters per second over second, which means my y-axis values are becoming more negative, while my x-axis values are positive. The way we define slope in math. So the other way that can we can have movement is this kind of curve. So I still have a general negative slope like I did in my pink line, but I'm starting to taper off and flatten out. So I'm still going backwards, but I'm slowing down. So going backwards means that my v versus t has to be in the fourth quadrant. Slowing down means I have to move toward the x-axis. So now I have a positive slope. So that means that my a versus t graph is going to be in the first quadrant. So positive, first quadrant. And finally, the other way that I can be moving with my object is I can be going forward and speeding up at the same time. Going forward means that my v versus t graph has to be in the first quadrant. And if it's in the first quadrant and I have to speed up, then my line has to be moving away from the x-axis. So if I'm in the first quadrant moving away from the x-axis, I have a positive slope, and I'm going to see this mirrored in the fact that my a versus t graph will be in the first quadrant. So a couple of things to recap. My a versus t graph will always be a horizontal line. The only question is, will it be in the fourth quadrant and how far down? Or will it be in the first quadrant and how far up? My v versus t graph will always be a straight line as well. In this case, there are slopes to my lines, which means that my velocity is changing. If I have a negative slope, then my acceleration will be in the fourth quadrant. If I have a positive slope, then my acceleration will be in the first quadrant. The quadrant that my v versus t graph is in depends on what my object is doing. If it's going forward in this green, it will be in the first quadrant. Going forward in this blue, in the first quadrant. If I'm going backwards, pink and purple, my v versus t graph will be in the fourth quadrant. Which way my line points in the v versus t graph, whether it's going toward the x-axis or away from the x-axis, depends on whether or not my object is speeding up or slowing down. If my object is slowing down, it is going toward the x-axis. So here it's slowing down because it's flattening out. So I'm going toward the x-axis. Here it's also slowing down, flattening out, so my v versus t graph moves toward the x-axis. If I'm speeding up, I move away from the x-axis. Here I'm speeding up, right, starting to get steeper, and so I'm moving away from the x-axis in my v versus t graph. Here I'm speeding up, so I move away from the x-axis, speeding up. So those are the ways in which a d versus t, a v versus t, and an a versus t graph will look if you are not moving at a constant speed in your direction of motion. So these are speeding up or slowing down.